Hi everybody. So in this video we're going to look at moments. And moments refer to the turning effect of a force about a point. So imagine that you're using a wrench to loosen a bolt. The longer the wrench, the easier it is to turn the bolt because there's a greater turning effect. So we have our bolt and our wrench, and the force is the effort you apply on the wrench. And the distance from a bolt to where you apply the force is called the arm. So we have our arm here, force being applied in this direction, and you can see that the force is being applied at a perpendicular angle to the arm. And the moment is the product of the force and the arm. So this is why moments are measured in Newton meters, because we multiply the force by the distance. Okay, so in example 1, we're going to find the moment of each force about the point P. So on this point here and this point here. And you can see that the force is being applied at a perpendicular angle to the arm of each point. So what we say is the moment about the point acting in a clockwise direction, because this force is acting upwards, so it would rotate in this direction. We can say in a clockwise direction would be the product of the force and the arm. So we have a force 4 newtons multiplied by the distance of the arm, which is 2 meters. So this will give us a moment of 8 Newton meters acting in the clockwise direction. So do you want to try and work out the moment about point P for question B? You can pause the video. When you come back, we'll go through the work solution. Okay, so the moment about the point P acting in a clockwise direction will be the perpendicular force, 5.5 newtons, multiplied by the distance of the arm, 4 meters. And this gives us 22 Newton meters in the clockwise direction. Okay? And in example 2, we're going to look at when the force is applied at an angle which is not perpendicular to the point. Okay, so in example 2, we're asked to find the moment of each force about the point, but you can see that this force is not being applied at a perpendicular angle to the arm. So I'm going to sketch this out. We have our point P, we have our arm, which we know is 4 meters, and then we have a force applied of 6 newtons in this direction. But this force of 6 newtons will have a vertical component acting in this direction and a horizontal component acting in this direction. So to work out this force which passes through the point, we can use trigonometry. This will be 6, which is the hypotenuse, multiplied by the cos of the angle 30. So it's the cos of the angle 30 because this contains the angle. It's easy to think that contains is cos, which means the vertical force doesn't contain the angle. So this will be 6 sine 30. And it is this force which will have a turning effect on point P because it's perpendicular to the arm. So the moment acting on P in the clockwise direction will be the magnitude of the vertical force, 6 sine 30 newtons, multiplied by the distance, 4 meters. We can work this out as 3 newtons, so this will be 12 Newton meters, acting in the clockwise direction. Okay? So do you want to try and work out the moment acting on P in question B? You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So the first thing I'm going to do is draw the diagram. We've got our point P. We've got the arm of distance 8 meters. And then we've got our force of 10 newtons with an angle of 120 degrees. So the first thing I'm going to do, I'm going to show the vertical component of this 10 newtons and the horizontal component. And we can work out this angle as 60 degrees. And what we're trying to find is the magnitude of a force acting in this direction, which is perpendicular to the arm of 8 meters. And because this force doesn't contain the angle, this will be 10 times the sine of 60. So a moment acting on P in the clockwise direction will be the force of 10 sine 60 newtons multiplied by the distance of 8 meters. We can work this out and we get approximately 69.3 Newton meters acting in the clockwise direction. Okay? And in example 3, we're going to look at resultant moments. Okay, so to define a resultant moment, this is the combined turning effect of multiple forces acting on an object around a point or an axis. And this is calculated as the sum of all individual moments. So for example 3, the diagram shows a set of forces, 1, 2, and 3, acting on this light rod. And we've been asked to work out the resultant moment about point P. So the first thing I'm going to do, I'm going to break this down into its individual moments. We've got 1, 2, and 3. And I'll begin by working out the moment about point 1. So this will be the moment of P. And because it's acting downwards, this will be clockwise. So we need to begin by working out the magnitude of this vertical component of the 4 newtons. We can see in this force it does not contain the angle, so this will be 4 sine 30. So the moment about P then will be 4 sine 30 newtons multiplied by the distance of 3 meters. We can calculate this as 6 Newton meters acting in the clockwise direction. And for our second moment, the moment acting on P, again in the clockwise direction, and we can see this force is acting perpendicular to the arm at P. This will be 2 newtons multiplied by the distance of 2 meters. So this moment will be 4 Newton meters, again in the clockwise direction. And for our final moment, moment 3, well, we need to work out this perpendicular force here. So this will be the vertical component of this 3 newtons. And because this force doesn't contain the angle 45, it will be 3 newtons times the sine of the 45 degrees. So this will be our vertical component of this force, acting perpendicular to the 5 meter arm 3P. So the moment 3P, acting again in a clockwise direction, you can see this is going clockwise, will be the magnitude of a force, 3 sine 45 newtons, multiplied by the distance of 5 meters. So this will give us approximately 10.61 Newton meters, again in the clockwise direction. So now we can work out the resultant moment. And because each of these moments are acting in the same direction, clockwise, all we need to do is add these together. So the resultant moment then will be approximately 20.61 Newton meters acting in the clockwise direction. Okay. Well, thank you very much for watching. I hope that's given you an idea about how to work with moments. If you did find that helpful, please like and subscribe. And you can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again and take care.